Okay, so sometimes the evaluation of an elementary integral cannot be evaluated or cannot be done since there is no elementary antiderivative of the integral. And in order to evaluate such, we're going to reverse the order of integration so that is expressing it as an equivalent iterated integral with the order of integration reversed. Okay, so let us have these examples. Double integral of e raised to negative or positive x squared dx dy from y over x to 1 and 0. Okay, so we're going to define the u here, and the formula that we're going to use is the u here, right? So we have now identified here u is x squared, then getting its differential, we have this as 2x dx. Okay? So as you can see, there is no exam, or I should say, we have an incomplete integral of the event, and that is the missing part is x. Okay, so we call that as antiderivative. There's incomplete antiderivative. So that we have now to reverse the order of integration. And how do we obtain the reversing order of integration? So we have now, when we change the limits, still the function will be e raised to x squared. Then we have now reversing the order of integration, that is from dy, then we have dx. Okay? So how are we going to obtain the limits now for this reverse order of integration? So we can have it from the given. A while ago we have here x is equal to 1, and then the other one is x is equal to y over 2. Okay? So let us have that. X equals 1, and then we have x equals y over 2. So you need to graph in order for you to identify the two limits. So that one is then the graph of x equals 1, it is the line, the vertical line, x equals 1, where it is 1 unit from the y-axis. What about x equals y over 2? So, if we're going to arrange the equation, we can also have this as y equals 2x. And by point plotting, okay, so by identifying the x and y intercept, let's say if x is 0, what is then y? Y is 0. Okay? Let us have another value for x, let's say when it is equal to 1. What is then your y? Y equals 2. So let us now plot the given points here. We have 0, 0, and then we have 1, 2. So where is that? Let us have this as the point now, 1, 2. Okay? Then let us now connect the 2 points. So this is now the region for the given curves x equals 1 and x equals y over 2. And with this region, we can now identify the new limits when we reverse the order of integration. Okay? So what stripping are we going to use? We make use of the vertical stripping. Why? Because we can see from the reverse that the outer variable of integration is now with respect to x. Okay? So with this variable of integration, which is the outer variable of integration, this signifies that what we're going to make use as a stripping is the vertical stripping. Okay? So from here we can now define the limits of variable of integration with respect to x. So look at the x coordinates. By looking at the x coordinates now, this will be the limits. Okay, that is from x equals 0 and then x equals 1. Okay? Because this is only the bounded points for the region. Okay? So that is 0 to 1. Then what about now for the inner variable of integration with respect to y? So the limits will be look at the strip, it is the vertical strip. So you just identify the endpoints of the rectangle and then identify the points now. So this is x, y. It is a point on the line and the endpoints of the rectangle. And then the other one is the endpoint of the other side of the rectangle with respect to x-axis. So this is x0. And then when you define now the limits for dy, it will be y up minus y down, so y, and then we have 0. Okay? So let us now identify or determine if we can now integrate this integrand in x squared, this time with respect to y and with respect to x. Okay? So as you can see, we have here e raised to x squared as our integrand, and the variable of integration is y. And with that, we consider that x is the constant, right? So in other words, e raised to x squared is constant, right? So with that, we can isolate e raised to x squared and then integrate now dy from 0 to y, then we have dx. Okay? So let us now integrate what's the integral of dy. The integral of dy is simply y, and then what's the limits from 0 to y? Dx. Okay? But what is y plus? We need to change y. The upper limit will change to 2x because this is the equation of the line, right? Okay, then applying now the limits that we have. So this now becomes 2x minus 0. So it's still 2x, right? Okay, let us now integrate this one step in the given integral. When we apply the limit. So what about now integral of e raised to x squared into x dx? So we have with us, our e now is 2 is x squared. And what is this differential? Differential is 2x dx, which gives us that we have a exact differential now because u is x squared and 2x dx is du. So therefore, this now transforms to e to the u du. And what is the integral of e to the u du? We have with us e to the u. And what is your u? X squared from 0 to 1. Okay? Then apply now the limits on variable x, so that is now 1 squared 1 minus e to the 0 squared, that is 0. Okay? So therefore, the answer now is e minus 1 because e to the 0 is 1. Okay? So that is now the double integral reversing the order of the integration. Okay? This is another example of double integral wherein we're going to reverse the order of integration. Okay, let us examine why we need to reverse the order of integration. Okay, so identify the integrand. It is cosine x squared. And what comes into your mind is that we're going to apply cosine, integral of cosine du, right? And identifying your u is we have x squared. And then when we now take the differential of u, so it is 2x dx. We don't have 2x in the given integrand. Okay? So that's why we need to reverse again the order of integration because there's lacking part in the integrand, and that is x. Okay? It's okay for us to have a lacking constant, but with regards to the variable, okay, we need to reverse the order of integration. Okay? So with that, we can now have cosine, integral cosine x squared, then we have dy dx. And again, we're going to graph x equals 1, and x equals y over 2. Okay? So let us now define the region. So when x equals 1, let us have this as x equals 1. And then when x is equal to y over 2, so we have again table values of x and y, where we have y0, we can solve for x, and that is 0. If y is 2, then what is x? So it is equal to 1, okay? So this is now your point 0, 0, then we have this as 1. Then let us now connect these 2 points. So the region now bounded by the two curves here, x equals 1 and x equals y over 2, is the region here, okay? And let us now define the limits of integration for this reverse order of integration, having now the variable x as the outer integration. So we make use of the stripping, which is a vertical stripping. Okay? And from here, let us identify now the limits for variable of integration x. So this is taken from the left and right endpoints of the region. So we have dash 0 to 1. Okay? Then what about for dy? So look at the endpoints of your rectangle and identify the given point. So we have this as xy, and then the other one is x0. Because for the first endpoint, the point is on the x at the line x equals y over 2, and this is any point, okay? While we have the other endpoint on the x-axis, so that's why this is x0 as the coordinates of that given point. So what is then the limits? So again, it is y up and y down, so we have it as y, and then we have it now as 0 for the lower limit. Okay, so when you now integrate cosine x squared dy, so we will treat x as constant, so therefore we will isolate cosine x squared. Then let us now integrate, or let us get the integral of dy from 0 to y, okay? So integrating it now, this now becomes integral of dy is y, then the limits is from 0 to y, okay? Then let us now substitute the upper limit with the given equation of the line x equals y over 2. We can also express this as y equals 2x. So this is then 2x as the upper limit now, then the lower limit is still 0. Okay? Then applying now the upper and lower limit. So this now becomes integral of cosine x squared. Then we have now 2x. So that is for y, and then 0. So just simply have it as 2x. Okay? So when you now integrate, again, x squared is our u, then getting its differential, that is 2x dx. So as you can see, it is exact differential. And with that, what is then the integral of cosine u du? It is equal to sine u, where u is, of course, x squared from 0 to 1. Then apply now the upper and lower limit. So this is now sine 1 squared is sine 1, and then sine 0. And we know that sine 0 is 0, so the answer here is sine 1. Okay? Then circle now your final answer. Okay, let us learn how to evaluate triple integral. So we have here number 1, the integral of x cosine y with respect to z, then with respect to x, then with respect to y, okay? So, examine the given integral, so where it has x cosine y, and the variable of integration is dz. So that means the integral here are both constant, okay? So with that, we can now integrate x cosine y as with respect to z. So copy x cosine y, then what is the integral of dz? That is z, okay? Then what is its limits from 0 to x squared? With respect to x, then with respect to y, okay? Then apply the limits on z, because we have here the first integral is with respect to x, with respect to z rather, okay? So that we have now, so copy the integral of x cosine y, then we have now apply the upper limit x squared minus 0, that's x squared, then with respect to x, then with respect to y, okay? Then we have now from 0 to pi over 4, then from 0 to 1, okay, combine now those x terms, we have this as x cubed cosine y. With respect to x, then with respect to y. Let us now get the integral of the given function with respect to x. So that is now, we have 0 to pi over 4. Since cosine y is a constant, so let us isolate the constant, which is cosine y. Then get now the integral of x cubed dx. So that is now x to the 4th over 4 from 0 to 1. Then we have with respect to y, okay? Then apply now the limits. What we have here now is 1/4, okay? Then 0 is 0 over 4, that is 0, okay? So in other words, this is now 1/4 integral of cosine y dy from 0 to pi over 4. So what is the integral of cosine y? That is sine y from 0 to pi over 4. Then apply the limits. We have now 1/4. Then we have sine pi over 4 minus sine 0. Let's apply the upper and lower limit. Okay. What is sine pi over 4? This is a special angle. So in degree, this is 45 degrees. Okay. So if we have this now as 45 degree by 45 degree angle, or pi over 4 by pi over 4, and then we have the sides measures 1, 1, and square root of 2. Then taking now sine pi over 4, whatever angle we have, because they are both pi over 4, so by definition, sine is opposite all over hypotenuse. So that is 1 over square root of 2, or taking now the conjugate or rationalizing it, we have square root of 2 all over 2. Okay? So the answer now here will be square root of 2 all over 8. Okay?